Good morning, good afternoon, good evening, whatever it might be, wherever you are. How are you doing this morning, Christos?
I am tired, but good. I'm on
Yeah?
holiday. I'm still tired. It's not crazy, but I had a good gym session yesterday, and that means that my body is feeling it today,
Well, I
punishing
guess
me
that's good.
for what I did. How's your gym going?
Good. I was there this
Yeah,
morning, and I was there yesterday. And
good.
nobody's there on Tuesdays, which is nice. Well, they've got like so many of the things blocked off, obviously, because of COVID. So they've got like
Yes.
30 ellipticals, but like 6 of them are available.
Well,
So I
because they
tried to
spaced them
go.
out and you can't use these, they put labels on them or something like that.
Yeah, yeah, yeah.
Ah,
So I was kind of like they're just not available. And I don't know what the deal was with this guy yesterday, but I mean, he was on that elliptical for like an hour. I was like, "Come on, dude, quit bogarting it. Like, just go take a walk." You know.
I
But
don't think
you
I can
know,
do 1 hour on the elliptical, man. That would kill me.
yeah. So anyway, and it's the sun finally came out. It's been raining and cold here for about 4 days, so the sun's finally out today, which is nice. Luckily, we are not in the Arctic temperatures that have plunged all the way down to Texas.
2 million homes without power this morning in
Yeah, it's
Texas.
crazy.
That's insane.
My in-laws got like 10 inches of snow up in Michigan. So the kids were like, "Well, let's go to Michigan. We want to go play in the snow." I'm like, "Well, we kind of needed
Now
to be there
let's drive
before."
over there. Yeah.
I was on his way to school this morning, taking my son to school this morning. He says, "Well," he's like, "Can we go to Texas?" I was like, "Why?" And he said, "Well, they got snow, and I want to go play in the snow." I'm like, "Well," I said, "Kiddo, you kind of got to be there first beforehand." So okay,
Yes.
you don't have any news because you're off this week anyway, right? So you don't have any news.
Yes, technically I'm off, but I'm here
Okay.
because I love you guys.
So this morning, I got some pings from people about some changes that Lastpass is making to their free product. Okay,
Mm-hmm.
and it took me about 7 reads before I finally figured it out. But so far as I can tell, essentially, you get to choose one type of device, either a mobile device or a computer, right? And that's the only device type you can use. You can use as many of them as you want, but only one or the other. So you can't like have
Who
a
thought of that?
computer. I'll tell you who thought of it. Don't open this door because I'm going to walk through it. I'll tell you who thought of it. The same people who thought that it was a good idea to buy .NET Reflector at Redgate and tell everybody they were going to have a free version, and then tell everybody, nope, JK, and then write this like completely self-serving blog post about how, oh, well, we thought people would buy our other stuff, but they didn't, and so we're going to have to charge money for it. Bearing in mind, of course, it was the guy who wrote this was the co-CEO. So we can't give away a free tool that was already free that we bought, but we can have multiple CEOs. Like, just the whole thing it just killed me. Anyway, I don't know. I guess they need to make money because the only way you can get around this now, as of March 16th, the only way you can do this with LastPass now is to buy. So you got to pay for it, premium
Well,
or families.
in that case, I would say move on to a different product. I have been using Bitwarden for the last year after moving off 1Password, and I couldn't be happier. It's available everywhere. It's free. It's very stable. I love it, and it came highly recommended. So if you're looking for an alternative to LastPass, then check out Bitwarden.
Yeah, so we've used LastPass for families for a really long time, and we switched to use 1Password. So I'm trying 1Password
Oh,
out to see
Password.
if it's
Never
any
heard
better.
of. I've been using Excel since BSD guy. Well,
That's one way to do it too. Don't let us, no judgment, right?
no judgment. Does it come
But
with a browser extension?
what, Excel? Some of the newer Excel add-ins are pretty persistent. There's one. So you remember Microsoft Money from 20, 30
Yes,
years ago, right?
I do. It came
So
around.
they made something called Money for Excel. It was like a plug-in for Excel or an add-in for Excel. I don't know what the proper term for it is anymore. So the money add-in lets you connect to bank accounts and stuff, and it pulls down all your transactions and whatever, and builds you a bunch of graphs, all that stuff. Which you look at it, you're like, oh, it's pretty cool, and it's in Excel, so it's sitting here, it's on my machine, whatever. Actually, seems to be an entire back-end service behind it, because I haven't opened it in about a month, and I get emails once a week saying, money in Excel, here's what you've spent money on this last week.
Yes.
So clearly it's an ongoing, it's more of an ongoing service rather than just an Excel, add-in. But
They definitely relaunched it maybe 3 months ago, and there was an internal kind of a trial, which was great. But
yeah. So anyway, so pretty light on news. We were off yesterday, so
yeah.
Yeah, but yeah, I was pretty blown away when I read this. I mean, we've used Family, so I guess it wouldn't have hit us, but shocked. Still.
In what world would you only be choosing one device to work on? Like I have 300 odd passwords somewhere. If I had to copy them from my phone to my laptop every time I need to use them, that's insane. Do I mail them to myself? It's crazy.
Well, there actually is there's another password vault that you could try.
Okay.
The Authenticator app.
Oh yes, I totally forgot about that. It now supports passwords. Yes.
Yeah. So there's in the Authenticator app. You can get the same, like in iOS and Android. It's like an autofill provider, and it's built into Edge. So if you have Edge Chrome, whatever, it just works, right? And if you've got if you use Chrome, there's an extension. And then they've got docs on how to import everything else. Like I've been importing everything between lots of different things just because I never know like what's going to be on a device when I need something. So it's like export from Lastpass, import into Edge, import to Chrome, import to Firefox, then export somewhere else. And so I don't know. It's a mess. Lord only knows. If somebody got a hold of my machine, there's probably CSVs full of passwords on here somewhere that I've forgotten to delete. It's just a total mess. But this might be worth trying too. And for us, like we use Work Profile, Android Work Profile at work, and which is absolutely awful. And I would highly suggest you not use it. But we are stuck with it, and it's awful. Like, you have to turn on a device-wide VPN for your Defender stuff, or whatever, like Sonos. What's it called? Sophos? I don't know what it's called. One of those device security things. Like I can't copy and paste between a Word document and a text message or vice versa, but I don't know. I don't like it. But it is an approved. It's like an allow listed app, so it's approved for use in Work Profile. And so if you want to have passwords in Work Profile and your company's locking it down, then because I can't get LastPass in Work Profile, so it's kind of cool. Yeah, kind of cool in that regard. So I don't know. Give it a shot. I haven't really tried it and put it through its paces, but I think it'd be pretty cool to try. So it's worth a shot anyway. So yeah, if you've got the Authenticator app, you've already got it. It's already built in. So yeah.
Yeah. True.
All right. So
kept up to date.
We have Thomas coming at noon Eastern, 9 Pacific.
That's right.
But in the interim. We've got some flows and grants to talk about today, yeah?
We do indeed. Continuing our identity crisis learning modules.
Yeah. So if you haven't been with us for the past, 6-7 weeks we've been doing this. Tuesday mornings we spend an hour and we sort of talk about identity more at kind of an educational level, rather than the practical level that we do during the show where we're implementing it into something or whatever. And so we've talked about building applications and what identity systems are and what user databases are and all that sort of thing. And now we're getting closer to sort of the practical implementation of that, of like, okay, cool, we've got these flows and these grants that we use, and the flows and the grants are the things that you as the developer use to interact with these identity systems, right? So if you don't, thanks P2A 2020 for resubscribing for 4 months.
Yes.
We still have to. We've got to get all of our charity stuff squared away so we can get all that subscription money to the right hands. But
AZ Wildfire will help us with that, finding the right stem
Yeah.
organization.
He's like he's a true Renaissance man. He does it all. So anyway, so today we're going to talk about flows and grants. We're going to take a look at a few of them. Kind of the most common ones that we sort of see regularly, right? Things that you as a developer are probably going to encounter, why you would use them in certain cases, and sort of what they look like. So we'll start. So you'll hear flows and grants thrown around a lot. It's kind of in everything identity related, right? It requires weapons grade level of pedantry to keep up with it all. And
Yes.
so in OAuth 2 we've talked about a little bit in the past. OAuth 2 is purely an authorization system. So it's purely a way to say, me user, I want to give app ABC access to read my calendar. And only read my calendar. It shouldn't have access to anything else in my account because maybe I've got a bunch of stuff in my account.
Yep.
And so OAuth 2 was purely for authorization. Well, that worked fine, except for that people were now trying to use it for authentication too. So you'd sign in with Google or you'd sign in with Facebook, which was really OAuth, in order to give an app access to your accounts in other places. But instead, developers would take that data and also sign you in with it, which... there was no alternative, so what were you going to do? Ask them for a username and password and then do it, right? There really wasn't a great way to do it. So we ended up with Openid Connect, and Openid Connect was sort of a bolt-on, an extension to OAuth 2. So with Openid Connect, you could now get both access to a user's stuff, but you could also learn who the user was and different properties about them, their name, all that sort of stuff. Well, so OAuth 2... flows or grants are called grants. So when you interact when you go through an OAuth 2 exchange with an authorization server with a service provider like a Facebook or Microsoft or whoever, that's called a grant. For OpenID, when you're also doing OpenID work to both, because you may get both, right? You'll end up with both signing a user in and also getting access to, say, their Google Calendar or something. That's called a flow. I don't know why they named them differently, but they are. So you have things like Authorization Code, which is both a grant on the OAuth side and a flow on the OpenID side. And we wonder why developers don't want to spend a bunch of time learning identity. And we call the same things. Technically it's different because, So anyway, the big thing, though, the big thing to keep in mind is we have this sort of concept of a user account. So this is a user, a person who's signing into a system, a person who owns something in a system, like my calendar data. And then we also have service accounts. These are accounts that are unmanaged, they don't have a user. So I'm not accessing a service account's calendar. I may need to access everybody's calendar because I don't know who the user is. There could be 20 users in my org. There could be 20,000 in my org. A service account doesn't have a user context, and so by virtue, a service account is essentially an administrative level of access, right? And if you look at service accounts and the kind of access they have, generally speaking, they are very privileged, right? So, I might be able to say, yeah, this app can read my calendar, me, John's calendar, but you as an admin would be able to say, well, you can read everybody's calendar because a service account doesn't know. Service account is all or nothing. But on the user account side, we have lots of different ways to authenticate users and get their tokens. So we talked a little about authorization code last week. We're going to revisit that again here today. We've got device codes, refresh tokens, and these two down here in red. We have implicit and we have resource owner password credential. Now, implicit is large.
Ones, right?
Yeah, that's why they're in red. So implicit is sort of how we did things until really just kind of a few months ago, maybe a year ago. And implicit was all about for single page apps, for client apps, stuff that's sitting on in a browser, a single page app, a React app, an Angular app, whatever. That's what implicit was used for, and implicit is probably the least secure of all of the different flows and grants that are out there. Most of it happens in the browser. It's very difficult to verify an application, so you don't really know what app is using this, right? I mean, you can guess, but there's no way for that app in the browser to securely store a secret. And so because of that, there's no way for the app to authenticate itself and say, yeah, I am app 123 and this is user ABC. So really all we had to go by was, well, this is user ABC, and I'm only going to let you send a token back to a specific URL. But that itself and alone is less about security and any sort of verifiable thing and more about the fact that you registered the correct DNS record, right? Orphan DNS records were a real problem with this, and especially test ones. So like if you had a bunch of test localhost stuff, or if you had some testing domain that wasn't registered on the public internet or something, it was only local or something like that, you start to run into some real risks of people being able to get tokens as your app, even though they're not actually your app. So implicit, we've largely moved away from in favor of PKCE, authorization code with PKCE, which we're going to talk about a little bit today. And then there's resource owner password credential. Resource owner password credential is pretty much just that. You're going to take the username and password of the user, the resource owner, right? So you want to access my calendar, I'm going to give you my username and password.
Yep.
It's a bad idea. Because even though I might say, well, you only have access to my calendar, you have my credentials and you can do whatever you want.
Yep.
And in the days of now where my Amazon account is linked to AWS and Washington Post and 48 other places, and your Microsoft account is linked to your MSDN subscription and some Azure subscriptions and your Xbox and all these other things, you really don't want to give your passwords out really for any reason, right? And in a lot of these services, password credentials don't even work anymore. So like in the case of Microsoft, if you have MFA turned on your account, resource owner password essentially just doesn't work anymore because there's no way to do MFA.
Which is good.
Because you're essentially making an API call with the username and password in the URL, and that's not good. Yeah. There is one case which somebody came to talk to us about actually a few weeks ago, which is for UI testing. Mm-hmm. So UI testing is so far about the only legitimate reason we've seen to use resource owner password credential. We see other people using it in the case of, say, mobile apps. So there was a person that I used to work with, and they ran the mobile practice place I used to work. Built a lot of mobile apps. And this was sort of a perennial discussion we would always get in, which is, well, I don't want to open a browser, right? Like, I don't want people to open a browser to sign in. Mm-hmm. And if it's, say, like, if you're building, Twitter V2, well, okay, like, you own the identity, and thus username and password is okay, right? But if you're signing in with another account, you don't want to get users in any sort of, you don't want to reinforce anything to a user that says, oh, I should totally just type in my username and password into this random application that I downloaded from the internet, right?
Yep.
So RPC has very, very limited use cases in 2020 and 2021. On the flip side, however, we have service accounts. And service accounts, really, there's no user, and there's nothing interactive about it. You'll notice that most of these over here that are listed, these all have some level of interactivity, with the exception of resource owner, where a user is doing something, a user is granting access, a user is giving you access to go and do a thing or whatever. And because of that interactivity, we can do things like MFA. We can enforce policy. We can change things about users before we send them over. We can verify things about the application that's calling. In service accounts, however, there's no user, and thus who's going to be interactive in the case of service accounts? And of course, that answer is nobody. And that's when we get into client credentials. And the client credential grant is just that. You use a set of credentials generated for a client application, so your back-end scheduled task, right, that's running on a server somewhere, your cron job, or a console app that's running as a service somewhere. They use their own credentials to authenticate purely as themselves and can access resources, all calendars in the org, all mailboxes in the org, whatever. So those are used by different kinds of apps. So we've got these two types of clients. We've got confidential clients, and confidential client is essentially something that can keep a secret. This is your web server. It's essentially your web server. I really can't think of any other cases where you'd have a confidential client. But Essentially, it's something where you can control access to the things that are going to be executing identity flows, right? Mm-hmm. So a web browser, I can send down to their browser, hey, go and do these things. But ultimately, my server itself is the thing that's going to handle talking to the identity system to exchange codes or do different bits of work. And so because of that, those clients can keep a secret. And by being able to keep a secret, they're called confidential clients. If you're
we have a question from J. Crow. What are the best practices for keeping client credentials secure?
We're going to talk about that in just a little bit. So yeah, we're going to talk about it in just a minute.
J. Crow.
In public clients, however, your cell phone, your desktop apps, things that run in a browser, you don't control the client really, in the sense that the client's executing on somebody else's hardware. And if it's executing on somebody else's hardware, there's no way it can keep a secret, and especially not a shared secret. So because of that, public clients don't have any way to keep a secret, and public clients, we have to treat them a little bit differently. That's where we get into things like public proof key code exchange and things like that. Which is a way for these apps to verify they are maybe the originator of the request, but not necessarily the app themselves. Because we can't have, if you put a secret into your JavaScript app, all we've got to do is open up the Web Tools console, and we'll be able to look at your code and find your stuff. Same with mobile apps, same with desktop apps. So the first one we're going to look at, Christos is going to talk to us about the device code flow. And device code is an interesting one. Yeah, it's kind of neat because device code is all about services that devices that you don't really sit in front of. I mean, you may sit in front of them, but you sit in front of them from 10 feet away, right?
Yeah, and there's no way to really interact with them. I mean, there is. I mean, if you think about your TV, they come with a virtual keyboard and you can start typing things. But imagine if you had to type a 64-digit password to sign into your device or whatever. So it becomes very impractical, and that's where device code flow comes in, where it allows you to perform the authentication on a separate device than the device that actually needs the resources access. So the very best example here, because most of the people can relate to this, is your smart TV, where you want to sign into Hulu or Netflix or what have you. Rather than you having to sign in on the TV, you are presented with an authorization code that you use to go and sign in somewhere else on a separate device that you have better access to. And that makes your life a lot easier, especially considering that most modern devices, phones and laptops come with keyboards and browsers. Next slide.
Yeah, I've tried to sign in. I've tried to sign into my Netflix account on my TV. It's not. Even like the Roku virtual keyboard, like I try to paste a password in from Lastpass or whatever, it just
doesn't work.
It's impossible.
Yeah, it's tricky. So this flow is fun over here because the client, which is your TV, right? It will actually go to a specific endpoint in order to get a user code. So you'll see the second line coming back to the client brings the user code. And the verification URI, that's the URI that you need to go to apply the user code. So the user takes the user code and the verification URI, and they go to their browser most of the time, and they apply the user code. At that point, they get redirected to the login server where they do the authentication. So you sign into your actual Netflix account there, for example. Then you take that back. At that point, or while this is happening, the actual client, your TV, is on a loop, listening and waiting for a response to come back. And once the authorization comes back, the client will use the client ID and device code, which is the second line from the bottom, to go back to the token endpoint to actually acquire the access token, refresh tokens, and ID tokens to sign you in. So it's very interesting that the actual resource of the client is doing this kind of a loop, waiting for you to do all the work somewhere else, and then it comes back. And as I was reading the RFC yesterday, I came across some security considerations when you're implementing this flow. So some of the things that you need to look after, for example, user code brute forcing. You've noticed that if you have used this kind of flow, the code that you get, the user code that you get, is usually 7 characters long. That means that it comes with a much smaller entropy, and that means that it could be brute forced. and somebody could be able to hijack the session. However, if the server employs proper rate limits and as a security implementer or whoever implements the authorization chooses the right length, then it should become really hard to brute force the password. Device crowd brute forcing, this is actually not visible to the user. So when you try to go through this flow, you don't have access to this one. That means that because it's something which is part of the software running this authorization flow, it can be very long, and therefore it can be protected from brute force. If you choose to have a smaller device code, then that could be liable to attack. Device trustworthiness. This is a little bit weird because, the scenario here is way far out, but in effect it allows for a man-in-the-middle attack, but either the manufacturer, so the TV manufacturer, or the authorization server have either been compromised or they're malicious. So imagine, Samsung releasing a TV and they want to harvest your credentials. And
well, hang on.
What?
Well, is it far-fetched? Imagine I bought a piece of network hardware, right? Mm-hmm. I don't know what kind. Say, a breezy, sunny network appliance, right? And its intention is to do, network monitoring and logging. And let's say that somebody managed to get a hold of the signing certificate for me, right? So, is it that far-fetched?
Probably not. I was thinking more far-fetched for the authorization server to be compromised.
Oh, well, sure. But the device itself, it's still, at the end of the day, it's still public client. It's still one of those things where a person could... somebody could put malicious software on their device, or like in the case of SolarWinds, supply chain gets blown up, right?
Yeah.
So I can see that. I don't know. Not to mention, have you seen? You see all the weird stuff that we see in security news and stuff about, here's a malicious app that was downloaded 10 million times on some store, on Play Store or whatever. And it took 10 million installs before somebody finally realized it. Or somebody handed off and took an open source project and sold it to somebody else, and the new maintainers are completely malicious or whatever. So, I don't know. I'm just like, if your TV is starting to melt because it's running like a crypto miner in the back end, I guess now you know why.
Yeah. So. Yeah, and it's crazy how many devices are connected to the internet these days. Like your toothbrush, does it really need to be connected to... to the internet and authenticate against a backend, and you have an account? It's just weird. But you're right. Wasn't it 2 or 3 years ago when they used IoT devices to launch the largest DDoS attack ever? So it was like digital cameras and toothbrushes that were being hijacked to run malicious hardware. So it might not be far-fetched after all. You're absolutely right. Now you got me worried. Like, who checks the Samsung TVs that are okay? Like, oh my God, I'm becoming paranoid. I'm becoming a hermit. I'm giving up on everything.
I don't know. I'm just saying, like, I've gotten way more paranoid in the past 10 years about, I don't know, devices in general. So, anyway, sorry, continue.
Yes. No, man, it's fine. Thanks for the commentary. Remote phishing, where you receive an email saying go and sign into your TV, and at this point there are instructions on the emails, so you are redirected to visit the verification URL and enter your code. That means that, however, for that to happen, the device needs to be on the attacker's possession, which is super weird. Like, why would I get you to sign into my device? Well, one way maybe is to actually use your account to buy services and movies and whatever, if that's the case. But again, it seems to be the reverse of what you would do in a phishing scenario.
Yeah, some people do remote phishing of it's actually all the phishing participants know, because it's your college age kid calling his dad and saying, "Dad, I need you to sign into Netflix. What's the code that's on your TV?" Yeah. My wife has a Greek account where
she needs access, and every so often they reset the password, so she has to call her brother, who has the Greek phone in his possession, to get the code. That's super weird. Then we have session spying. Now imagine you are sitting in your living room trying to set up your Netflix on your TV, and somebody with binoculars across the street is trying to actually see the code that your TV is emitting, and they manage to sign in before you sign in using the code. And that is apparently something that can happen. And to mitigate against that,
doing it, you're sitting at work, somebody's shoulder surfing, or you're trying to sign into the big TV, Although, I don't really know.
What?
Yeah, I don't know why you would do that. Like, because if I'm going to use the device code, then now I guess it depends on, do you sign in first or do you show the device code first? That's probably the big difference, right?
Yes.
If you signed in and all you got to do is consume the device code, then but even then, now you're linking your TV to somebody else's. I don't know. Whatever.
Exactly.
It's a weird.
Some of these security considerations are not always things that make sense. Like, because in one of the scenario, somebody gives you free Netflix. Rude. Multi is saying someone is giving you free Netflix. That's so rude. I know. Using somebody else. I mean, if somebody else is watching stuff that are totally not relatable to me, that could be an annoyance, right?
Yeah.
Just to spite me.
They could totally screw up your recommendations, right? I mean,
exactly. That's what I'm saying. Like, imagine having all these, rom-coms.
We left our we left our Netflix signed in, I think, at my in-laws, and like every time we open it, it's like a million westerns, and talkies.
Yeah, or kids recommendations on your main page, right? Because they hijack your.
PSD guy says so much honey boo boo. I know. See, that's exactly what happens. You turn it on. You turn on your. Although I was browsing through Discovery Plus the other day, and it's like, I don't know. Like, some of the stuff in there's neat, obviously, like the old school, like MythBusters and Deadliest Catch and all that sort of stuff. But man, some of these new shows, I'm like, this just seems like an extremely specific sort of stretch, my 1,200-pound life. It's like, what? Why would anybody want to watch that? I don't know. Maybe, it's just a me thing. I don't know. I just wouldn't want to watch that.
No. Talking about shows, there's a fantastic show coming back for season 2 for all mankind. If you haven't watched this one, it's on Apple TV though. So apologies for getting everybody excited and then talking about Apple TV, but imagine a world where the Russians landed on the moon first, and then the Americans had to play chase, and then it escalates to this kind of crazy scenario where they occupy the moon and try to define the territory. It's brilliant. So if you haven't watched it, highly recommend it. It's coming back on the 19th. So excited. Back to the code. Non-confidential clients. Absolutely true. If you are signing in on TVs and other devices, they are definitely public clients. So they should be treated like that, and there should be no client credentials whatsoever in there. And finally, non-visual code transmission. Again, trying to make it, oh my God, I'm being pixelated and disappearing from the screen. What's happening?
I know your voice kind of went out.
I've been
too.
Disappeared. I've been sent to the moon.
Well, it's snowing out where you are, right? It looks like you're captured underneath a giant snowdrift right now.
I am back. He's been censored by big tech, by the big TVs. LG and Samsung are hijacking our.
See, they're onto you. We're exposing somebody's.
LG. Damn it! They heard it.
Somebody. We just exposed somebody. I know.
We did. Beat me up. Yes.
All right.
What is this? Anyway, let me continue with my the final one. Non-visual code transmission. So if your neighbor is peeping with his binoculars into your TV, then there's a way to mitigate that attack by actually transmitting the device code either through text-to-speech or through Bluetooth. So rather than displaying it on the big TV and everybody having access to that, you could use something like voice or whatever to pass the code to the user. There you go.
I remember.
And then,
I remember in the early days, like when Disney Plus, like when the first apps came out. I remember you had the option then when you turned on when you started up the TV app, you had the option to open the app on your phone, and it would essentially sign you in that way, which I assume is sort of the non-visual code, right? I think YouTube or YouTube TV kind of lets you do that too. So
it does it, which is annoying because I have an Android phone as well, and sometimes when I need to sign into Google-related stuff, my phone will just say, "Are you approving this?" And it will do it, which is a great user experience. However, it means I need to have my phone with me at all times for that to work.
Well, I know we use the Google TV Chromecast thing, like the little white oblong thing, and those things, when you sign in with your Google account, they pick up all the Google Smart Lock passwords that you've synced in. So it's actually really nice because like you open up an app and it just signs you in. It's just done. I was like, oh man, this is nice. I get used to this. I mean, I hate the fact that we got Google stuff all over each TV, but it's super convenient. I guess that's the price you pay. The trade-off between privacy and other. Okay, sorry. Anyway, continue.
No. We have some interesting comments. Like one of them is on the Microsoft Developer channel where Rocklane is asking, how did you make SSO in mobile devices public clients? For example, the login on the mobile app uses Azure AD app, and I have some web apps with the same login. And I have given permission to sign in directly in the permissions on the Azure Active Directory. So SSO on public clients.
So that's mostly the web view part. So if you use System Browser to sign in, then you'll get SSO. Because the System Browser has the context of the other apps that you've accessed and has the context of being signed in already to Azure AD. So instead of embedding a web view, use the System Browser to sign a user in. If part of the app is a web view, I don't know. There may be some techniques depending on the web view, because I think in Android there are three different things. There's System Browser, there's like a web view, and then there's a third control, which I'm not entirely sure what that control is. Some of those, there's a certain control that is completely isolated to your app. So the cookie containers and everything are stored within your app, meaning once you sign in once, subsequent sign-ins in that app are going to stay there, right? They're going to be persistent. But there was another one I thought that sort of spanned the two, where it was it had the option to be totally throwaway, but it also had an option to use the cookie container of the System Browser. But I don't know. We'll have to look into it and see what the best way to do it is. But using System Browser is one of the most sort of guaranteed ways to get SSO from a device. There's also Broker Auth, where you use the Authenticator app. We'll find a link for getting Broker Auth set up. So like in an org scenario where I'm already signed into the device and it's a managed device and I've got Authenticator on there, your mobile apps can use Authenticator as opposed to using the browser to sign a user in. So then the MFA and everything happens for them right there because they're already in the Authenticator app. So, yeah.
Nice. Bolt is saying, my favorite is when I attempt to project my laptop to the incorrect TV, and it's my neighbor.
Just get a projector and project it on the side of their house.
Exactly. Make it public. Right. Client credential flow. This is a fun one, and this is probably the only one where we covered before about service accounts, right? So this is the case where you have a daemon app or some service that needs to run in the background without any user interaction. This is not a user signing in. This is the app actually signing into itself. And then, as JP mentioned earlier on, usually with an elevated set of permissions because they need to view all calendars and have access to all calendars in order to execute some kind of functionality. It's important here that when you use this flow, things are locked down. So, in Azure AD, you need to, for example, you could lock it down in terms of how and what resources you can access. It's pre-agreed, so they don't go and roam freely on whatever it is. And the flow is pretty straightforward. You actually provide a client ID and a client secret, i.e. a username and a password. You send it to the token endpoint. You get the token back. for a specific resource, and then you use that to call an API or whatever resources you have in the backend. The API or the backend, your other service, needs to validate the token and then return the data back to. It's not a web server app. It's any app that uses that. And technically, a web server app would not be using a client credentials. So we need to probably update that flow. That doesn't make any sense. But anyway, that's the flow. I mean, that's pretty straightforward. Again, it needs to be a confidential client. You can't really use a public client because putting a username and a password somewhere that can be reverse engineered does not make any sense. So please be careful when you use this one.
Yeah, client credentials. We actually had some questions this morning about client credentials, and GA Crow is asking how do we keep them secret, how do we store them, how do we secure them, whatever. We're going to get that in here in just a minute.
Yep.
The big thing, the big flow now is authorization code. So authorization code is sort of, it's the one, right? This is the one that everybody asks about, and the one that we want to drive everything to, because with the addition of the Pixie extension that happened in OAuth 2.1, it is, I guess Pixie's been around before 2.1, but I think the fact that it's going to, I believe, be required in 2.1 means this is sort of the de facto standard, pretty much for everybody, and it solves a really specific problem, but we'll talk about that when we get closer to the flow, right? And Bolt's got an issue with LDAP, Radius, and Wi-Fi with B2C. You were not the first person to ask about that. And yeah, let's talk about it. Let's talk about it later, because I don't remember how we solved it earlier, but I think there might be a very roundabout solution. So anyway, so let's look at
make sure to join the Discord.
Yeah, that's true. Yeah, join the Discord for sure.
At the very top, you can see all the links. We have talked about support, JP, so we'll do a very quick break to talk about support and help.
Sure. We can talk about support. So we've got a team. You'll notice at the top of the screen, right under Get Help, you use that link. That will take you to Microsoft Q&A. And Microsoft Q&A is sort of like a Stack Overflow-esque type of a thing, although less toxic, I guess. I don't know the right way to describe it. It's like a friendly Stack Overflow.
You need to work on your diplomacy, JP.
What's not diplomatic about that? I mean, have you ever asked a question? Have you ever asked a question? I mean, last time I asked a question at Stack Overflow, they said, actually it wasn't Stack Overflow, it was Server Fault or one of the other Stack Overflow related ones. Somebody closed it immediately and then chastised me in the comments about like, oh, well, this isn't for workstations, this is for servers. And I'm like, okay. I mean, it doesn't say that anywhere. It doesn't say. I guess it doesn't say workstation fault in the name, but it was super, super unpleasant. And here's the thing. I finally figured out that problem as to what the problem was like 2 or 3 years later, and it was some sort of bug in like Intel TXT and the BIOS and TPMs and how they all work together, and absolutely impacted servers too. And I think this guy just wanted to be unpleasant. So I don't know. It was awful. It was miserable, and I just don't go out there.
It's a difficult environment for new people to ask questions.
It's a difficult environment for anybody. I'm just saying. Like, I'm not saying like there's plenty of the world's software runs on copy and paste from Stack Overflow. Don't get me wrong. I'm just saying, like, it can be a relatively unpleasant place to be. But, more importantly, we have something called Q&A where people aren't necessarily that, aren't that unpleasant.
Yep.
And that's where that link will take you, where we have engineers on our team who are out there to help you.
Make sure to use it.
So make sure to use it. Of course, you can always join our Discord and come and talk to us, although we're not sure how much we'll be able to help you, but you can always come and join the Discord. We are happy to help as much as we can. Or just send us an email, 45show at Microsoft.com.
Microsoft.com. Yeah, perfect.
All right, let's see how much of authorization code flow we can blow through in 12 minutes. You ready?
Yes.
Let's go. Okay.
Let's do this.
So in the authorization code flow, right? Authorization code, the whole point of the authorization code is that you have a user, and the user is sitting there, and the user is able to do an interactive login, right? Like, that's the key. The user goes and signs in, the user's in front of a browser, a web app, a desktop app that pops open a browser or whatever. But we'll stick to web apps for now. The user goes to sign in. Instead of the tokens themselves being sent back to the browser, right? Oh yeah, sorry, Ultramark. Yeah, there's auth code for service accounts. I don't really know how that would work because you've got the credentials because it's a service account, and so because you've got the credentials, it would be a client credentials flow. Yep. So the user goes to get signed. So the first thing, a user comes to your app. We don't know who they are, so we send them over to the identity system with a bunch of things and say, hey, please sign this user in. I want you to sign them in. I also want you to give me access to their calendar or whatever. The user does whatever. They sign in. They might consent. They might do MFA. They might do all the different things they have to do to get signed in. They send a fax to somebody. I mean, whatever their organizational policies or their policies are that are set up, the user signs in. User does all that. You as the developer don't really have control over all that because it's not necessarily your identity system. Perhaps it's their organizational policy, whatever. User goes and signs in, then they get sent back to the application in the browser, right? So because this is happening in the browser, we don't want to send any tokens in the browser if we don't have to, like an actual ID token or an actual access token. Instead, we send back this code, this one-time use code or few-time use code. But it's only valid for a very short window of time, usually measured in single-digit minutes, sometimes even in seconds, less than a minute. So that one-time code is what comes back in the browser, and then your back-end web server takes that code and sends it down to the authorization server, to Azure AD, to Auth0, Okta, whoever, whatever your AS is, your authorization server is. That's this green line, this server-to-server channel. So the server-to-server channel, the app calls the back-end identity system. It says, hey, this is who I am. This is the code that you gave this user. I would like the things that the user said I could have. And so then they get sent back, right? So then the app gets its ID tokens and access tokens that way, and those tokens are only on the server. They never touch the browser, but the user signed in, and we can go call some downstream service or whatever it is that they'd like to do, right? So this is cool, except the app has to authenticate itself somehow. That's the key, right? Is not only has the user authenticated, and we've been provided this code by Azure AD, the app itself needs to say, hey, I am actually the app for whom this code was generated, right? So how do we do that? Well, we end up using some kind of a credential for the application itself, right? And that application, in some cases, is just a secret. It's just a string secret. You generate it in the portal, and so here's your client ID, here's your client secret, and away you go. We'll talk about those in a minute. But at some point, the app server needs to identify itself when it makes that server-to-server API call to say, hey, I've got this code. The application server needs to identify itself to Azure AD or your identity system, say, I am actually who I say I am. Provided that the credential is correct, authorization server sends that back down to the app, and away we go. So now there's a new one called PKCE, Proof Key for Code Exchange. And where this gets interesting is this we can actually use inside the browser or not. We can use this in the browser. We can also use it with a traditional web app. And it's not necessarily a way to generate a secret per se, as much as it is to generate or to verify the fact that the app that requested this user to go and sign in is the same app that is going to receive the tokens for them. So I can't remember the exact name of the attack, but there's an attack where essentially you grab the code and you go redeem the code before the app server can go and do it, right? So it's kind of a man in the middle. With Pixie, we get this extra layer where we essentially hash some data, right? We send that hash in this code challenge. We send the hash in the original request. So when the user first goes to the authorized endpoint and is asked to sign in, we send this code challenge along with it. And it's just a hash of a piece of data. It could be, it's a string or it's whatever, right? When the user gets redirected back, it's still got the one-time use code. But what's the difference here is that there's also what they call the code verifier. And the code verifier gets sent back to the authorization server in that back-end call. So in the server-to-server channel, Then we say, hey, here's the code verifier, which is the unhashed string that we used earlier. If the authorization server can hash that string the same way that was sent in the original request, then it's considered valid, and then it gets sent back. Now you may also still have a client credential there, because they're kind of and like Robertable said, he says he heard that Pixie negates a man-in-the-middle type of attack, where a compromised browser extension can exploit it, and that's absolutely true. It's to prevent somebody from grabbing this one-time use code that gets sent back in number 4 after the user is signed in, is to prevent that code from being reused somewhere else. Because presumably a malicious Chrome extension or malicious browser extension may not necessarily know what that secret is, or what that shared what that shared code verifier or code challenge actually is. So the whole point of it is to make sure that the app that started the request is the app that is redeeming the request once the data comes back. That's really the big driver behind it, right? And as a side effect of also, because we can do this, because we can verify that the app that requested it is the app that's consuming it, it also has the benefit of this works in browser apps. This works in a Blazor app and a React app, an Angular app, something that's running in the browser, because we can do that verification between the two, right? So on those credentials, let's talk really quickly about client credentials, and then we're going to switch over because our guest has arrived, and I'm excited about that. So, a note on client secrets. Now, in Azure AD, and in most authorization servers out there, you have more than one option of how to authenticate your client. Now, this is not authenticating your user. This is how your app over here on the right is going to authenticate itself back to the AS whenever it needs to do something. This is applicable here. In this case, it's also applicable in what Christos was talking about with client credentials and with client credentials. So when we have a secret, so I've gone to the portal, I've generated a secret, or I've added a secret, right? I've somehow or another gotten this secret. Well, remember that we both know about that. I know about it in my app, and you know about it in your authorization server. So your Azure AD, your Okta, your whoever, they're all going to know what that shared secret is, because they have to, because it's just a password. It is essentially a username and a password. Client credentials is really not dramatically dissimilar from a username and a password, because I have two strings of data. One is sort of secret and one is absolutely secret, and that's what I use. And if you look down here in the bottom, you'll even see when you do that last step of the authorization code, as an example, you send the client ID and the client secret. That's what you're posting in. So there's nothing particularly complex about that. It's just a string, right?
Yep.
So that's cool. It works, and in fact, I'll show you something here in just a minute. It works, and it's kind of okay for development. You would not want to do this in production unless you sort of understood the risks, right? There are some cases where generating certificates and the certificate hygiene required to sort of manage the certificates could potentially put you at bigger risk than just using these string secrets, especially if there's really like no sort of comfort or anything with anybody managing the life cycle of these certificates. So let's talk about certificates. Now, in the case of certificates, I generate a certificate, so I've got a public key and a private key. I only give the public key to Azure AD. I keep the private key for myself. So Azure AD will never see my private key. It doesn't need it. I can store that in something like a key vault. I could use my on-prem certificate authority. I could store it in any number of different places. Windows Search Store, and then have a super lockdown VM. Like, there are all sorts of different ways to store a certificate securely, to store your private key securely on your machine or on your compute that's running, right? Or as Bolt says, when they send you your certificate in an email, and you have to go get it regenerated, because we all know email, the most secure of mediums. But when we're doing certificate credentials, so when we use a certificate to authenticate to Azure AD, what we end up doing is, instead of giving our private key to Azure AD and just using that, we end up signing an assertion. And that assertion is just essentially a JWT with certain values in it. So the same way that we would have, like, that we receive a JWT that has all the different user claims in it, we are instead going to generate a JWT, and then we're going to sign it with our private key. And by signing it with our private key and generating that signature, when we then send in that assertion, that blob of text to Azure AD as our secret, Azure AD, because they have our public key, can then verify, oh, this came from this actual application, right? So it's an alternative way to doing secrets, but it's sort of a one-time use thing. If my secret gets compromised, I got to go update my app. I've got to update anything that's depending on that app.
Yep.
In the sense of CI pipelines or anything like that. I've got to go deal with that sort of that secret exposure on my own. I've got to roll it over on the authorization server side too, and say, "Wow, this secret's been grabbed, so we got to do something about it." When we're using certificates, now it's a matter of, well, how do we secure our private keys and how do we hold our private keys somewhere where they can't be inadvertently leaked, or where only the right things have permission to access them. And in some ways, there's we've been storing certificates and private keys longer in some ways. And so there are lots of, in some ways, pretty low-level things like certificate authorities, like the Windows Search Store, for storing those certificates, or storing them in certain places in the file system in Linux with certain permissions, so that those private keys can't be accessed by things that don't need them. We also have the advantage of being able to do things like roll those keys more frequently. So if you've got automation that rolls your keys every 30 days or something, or only gives you a 90-day validity on that certificate, it makes it much easier through APIs to automate adding those back to your Azure AD as a set of client credentials, to say, hey, I've created a certificate, please add this to the valid list. Let that roll for a couple of days, and then go remove the old ones when the old ones are no longer valid, right? So the reason that we see this, there's more security here, obviously, because we're never exposing any of our sort of key material. We're never exposing our private key. But especially larger organizations tend to have somewhat better hygiene when it comes to certificates, in terms of rolling the certificates, having policies around who can access certificates, why they access them, how they access them, all that sort of stuff. And I think because of that, we see those types of organizations be more successful with this, because it's just a certificate, just like every other certificate that they have to generate for either devices or for web servers or for anything else that's happening. We lost Christos. I don't know what happened to him. Okay, you're back.
I'm back.
So
I'm back.
Certificate hygiene in organizations tends to be a little bit better, and so because of that, it makes it a little bit easier to know when they're going to expire, schedule their renewal, put new ones out there. There's just a whole lot more process involved than a secret that I generated at exactly 12:01 p.m. on Tuesday, February 16th, that I know is going to expire in 1 year. And so at 12:01, I've got to put a note on my calendar or something to go back and rotate it. Okay.
I am transforming to pixel dust, and I think that's probably because we have to come out of MS Learn and get our lovely guest, Thomas, who's patiently waiting on the thing.
Yeah. So we are done on Learn TV. We'll be back next Tuesday with the same thing. For the moment, we're going to take a quick break. We're going to get our guest in here, get him all squared away, and go ahead and get your coffee. Get refilled. We'll be back in just about 5 minutes.